Okay, in this lesson we're going to answer two essential questions. One is, how do I find the volume of rectangular prisms? And two, how do I choose the most appropriate measure to solve real-world problems? So let's talk about what volume is. This is page 245 in your workbook. The volume of a solid figure is the amount of space occupied by the figure, how much space it takes up. Volume is measured in cubic units. That's so very important to remember. Cubic units. Cubed is when we use the little 3. When we talked about area, we did squared, and we had the little 2. Now we're going to use the exponent 3. How can you measure the amount of space each of these rectangular prisms takes up? How much space is inside each of the rectangular prisms? How many unit cubes does it take to fill the rectangular prism? So to answer this question, I guess it would help if we choose a cubic unit and fill each prism with them to see how many unit cubes it takes to fill. So when I say unit cubes, and we're going to get into this soon, we're talking about cubes that maybe are centimeter cubes. So each cube is, 1 centimeter long, 1 centimeter wide, 1 centimeter high. Maybe they're inch cubes where they're 1 inch wide, 1 inch long, 1 inch high, that kind of thing. So if you look further on page 245, you see the definition of a unit cube. A unit cube is a cube with each edge that's 1 unit long. The volume of a unit cube is basically 1 cubic unit. It can be written as 1 cubic unit or 1 unit cubed. So look at number 2. Label the length, width, and height of the centimeter cube on the right. Write the volume of a centimeter cube in 2 ways. So if this is a centimeter cube, I know the length is 1 centimeter, I know the width is 1 centimeter, and I know the height is 1 centimeter. So that means that the volume of this centimeter cube would be 1 cubic centimeter, or we can write it as 1 centimeter cubed. So I'll use the little exponent 3 to say cubed. What if we have, look at number 3, what if we have an inch cube? Well, that means that it's, 1 inch long, 1 inch wide, 1 inch high. That would be 1 cubic inch, or 1 inch cubed. Or maybe if it's a meter cubed, so it's 1 meter long, 1 meter wide, 1 meter high. So 1 cubic meter, or 1 meter cubed. And you get the idea. A foot cube would be 1 cubic foot, or 1 foot cubed. A yard cube would be 1 cubic yard, or 1 yard cubed. So that would be a bigger cube, right? Because you're talking about a cube that's a yard long, a yard wide, a yard high. Now, some people get volume and capacity mixed up. Volume is the measure of the amount of space an object takes up, and most people think of capacity as a measure of how much a container can hold. But here's where the really big difference comes in. Volume is measured in cubic units, like cubic centimeters, cubic inches. However, capacity is usually measured in liquid units. That's like milliliters, anything with liters, gallons, ounces. So capacity is when we're talking more about liquid, and volume is how much space an object takes up, or how much space is inside an object. So how are surface area and volume different? We talked about surface area in Unit 4. And take a look at this cube here. Let's say that this is cubic inch. That means that it's, 1 inch long, 1 inch wide, and 1 inch high. So let's say this is a cubic inch. Well, the volume of it would be, 1 inch cubed, or 1 cubic inch. That's how much space it takes up. It's literally a cube. But the surface area of an inch cube would be different. If you remember, to find the surface area of a cube, you just have to do 6 times the side squared. Well, the side is, 1 inch. So I'd have to do 6 times 1 squared. 1 times 1 is going to give me 1. That means the area of just one of these flat faces is 1. And I have 6 of those flat faces in a cube, so that means the surface area would be 6 square inches. It makes up 6 flat square faces that are an inch each. So 6 square inches. Volume is very different than surface area because volume is, volume is the number of cubic units that fit inside an object. Surface area is the total area of all the flat faces. So remember, surface area was two-dimensional, right? We're still talking about flat two-dimensional faces. That's why it was always squared. Now when we get into volume, now we're talking three-dimensional. We're talking about filling it with cubes, which are three-dimensional figures. How is the unit used to measure surface area different from the unit used to measure volume? Well, here we go. Surface area is measured using two-dimensional units, which are square units. So maybe you're measuring in flat squares like inch squares or centimeter squares or mile squares, but they're still squares. They're flat. They're two-dimensional. And volume is measured in three-dimensional units, cubic units. All right. So take a look at this prism here on the right of number 11. What if we were to tell you that all of those cubes, all those green cubes in the middle, are centimeter cubes? That means each one is a centimeter long, a centimeter wide, a centimeter high. So what is the surface area and what is the volume of this prism where you're making it up with centimeters? First, I might actually start with volume because I said that each of these are centimeter cubes. So it looks like I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 cubic centimeters. I have 10 cubes that are centimeter cubes. So 10 cubic centimeters make up this rectangular prism. Now remember, surface area is two-dimensional. That's just the area of all the flat faces. So remember, in a prism, you've got 6 faces. Well, in a rectangular prism you do. You've got a top, a bottom, a left, a right, a front, a back. So let's talk about the surface area. If I start with the top, let's see, I've got 2 times 5 here. I've got 10. And that means the bottom would also be 10. I've got the left side which looks like it's just 1 by 2, so it's 2. So left is 2, which means the right would also be 2. And then, oh, I have to get the front and the back. So here's the front. The front would be 1 by 5, so the front has an area of 5, and that means the back has an area of 5. So if I put them all together, the area of the top, the area of the bottom, the area of the left, the area of the right, the area of the front, the area of the back, and put them all together, I'm going to have a surface area of 34 squared centimeters. So you can see the difference between surface area and volume. The numbers are very different. Write a formula for the surface area of the prism. Well, if you remember, we had that long formula, 2 times length times width, which basically is going to give you, let's see, length times width. That would give you the bottom and top. 2 times length times height, well, that would give you the front and the back. And then 2 times the width times the height, that would give you the left and the right. So there's our formula for surface area, and you have that on your formula sheets. Number 13, write 2 formulas for the volume of a rectangular prism. Well, I don't know if you noticed this, but there's actually a very easy way to find the volume of a rectangular prism. Let me just erase this here. So here's the secret, and you might have already heard this before. You want to figure out your length, which is 5 in this case. Figure out your width, which is 2. And also figure out your height, which is 1. So you can do 5, which is your length, times 2, which is your width, times 1, which is your height, and you're going to get 10. Remember, we said the volume was 10. What we did was length times width times height. The formula for volume is a whole lot easier than the formula for surface area. Length times width times height. Another way you could look at it is if you know the area, if you know the volume of just one layer of your prism, you can figure out the volume for any number of layers of the prism. Because you can think of it this way. We've got this rectangular prism here, where it's 2 by 5. That means that one layer of this prism would be 10 cubic centimeters. Well, what if I have 2 layers? What if I made this prism taller? Well, then I would have to do 10 times 2. What if I have 3 layers? Well, then I'd have to do 10 times 3. Each time I'm taking one layer, which is basically, you know, the volume, or I guess you could say the area of the base, the bottom layer, and then timesing it by the height. So another formula that you may see looks like this. Volume equals capital B times H. Notice it's not a lowercase b. That's very, very important. The capital B means the area of the base. If you know the area of the base, then you can times it by the height after that, because that'll help you to figure out how many layers or how tall your rectangular prism is with the volume. So let's take a look at numbers. We're just going to do 14 and 15. You're going to do 16 on your own. We're going to find the surface area and the volume of the prisms. So if I start with number 14, the surface area, let's see, it looks like the top is 5 by 5, so that's 25. And then the bottom would also be 25. And then the right is 5 by 5, which is 25. The left is 25. And of course, the front and back are also 25. That's because this is a cube. All the faces are the same. So if I do 6 times my side squared, or 5 squared, which is 25, and then times it by the 6 faces, I'm going to have my total surface area of 150 square inches. Now, if I apply that, or if I use that same idea with volume now, let's see, 2 ways to look at it. One way is to do length times width times height. The other way is to do the area of the base times the height. So the length is 5, the width is 5, the height is 5. 5 times 5 times 5 is going to give me 125. Or I can do it this way. The area of the base is 25, right? Because 5 times 5 is the area of the base. And then times that by the height, which is 5, and 25 times 5 still gives me 125. So there's two ways to do that. Either way, I'm going to get 125 cubic inches. So that whole cube is actually made up of little 125 inch cubes. Take a look at this rectangular prism for number 15. Surface area. I might use the formula here. 2 times length, which is 8 maybe, times width, which is 3, plus 2 times length times height, plus 2 times width times height. And let's see. I will move this down here. 2 times 8 times 3 is going to give me 48. 2 times 8 times 3 is going to give me also 48. And then 2 times 3 times 3 is going to give me 18. And when I add it all up, 48 plus 48 plus the 18 is going to give me a surface area of 114 square feet. So that means all the faces of my rectangular prism are going to have areas totaling 114 square feet. Now for volume, I'm going to go back to a different color. Volume, remember, two ways to do it, length times width times height, or the area of the base times the height. So let's see, the area of the base would be 3 times 8, so that's 24. And then 24 times my height of 3, and I'm going to get a volume of 72. Or I can do length, which is 3, I guess, width times 8, and then the height, which is 3. So 3 times 8 times 3 is still going to give me 72. So 72 cubic feet. And on the last thing I want to talk about is when it's appropriate to use some of the different measures that we've talked about. We've talked about perimeter, we've talked about surface area and area, we've talked about volume. So now it's important to know when to use each of those measurements. What if I'm talking about the distance around a building? I kind of gave you a clue there. Around. The distance around a building. Hopefully you recognize that as a perimeter measurement. You're looking for the distance around an object, in this case the building. What if it's the amount of wrapping paper on a gift box? We've done a couple problems with this before. If we're talking about wrapping paper, we're covering the outside faces of a box. That's going to be a surface area problem because you're talking about just the area of the outside faces. And then 21, the amount of sand in a sandbox. Well, now we're talking about inside a three-dimensional figure. How much space is in there to fit the amount of sand? This is a volume problem. So it's important to know when to use each of these measurements. And that brings us to our takeaways. I have the definitions for volume, cubic unit, and what a unit cube is. I also included both formulas for finding the volume of a rectangular prism. And last, this is very, very important. You need to know the difference here between perimeter, surface area, and volume.